Let's see this question number 3.34 of Irodov. The question states, find the potential phi at the edge of a thin disk of radius r carrying the uniformly distributed charge with surface density sigma. So here is a disk of uniform density, charge density sigma, radius r, and we have to find the potential at an edge point. So suppose I take this a point on edge. Here we want to find the potential due to hold this. So let me draw a diameter through this point. Suppose this is a diameter. The key here is take the right element. So the element that I will be taking would be an arc of a circle whose center would be at P. So element would be something like this. Suppose I take this element. This element is an arc of radius r, and this element subtend angle 2 theta at the center. So like this, symmetrically theta here, and obviously element should have some width. So the width of this element is dr. So this is my element. So what is the charge on this element? So before charge, let's area of this element. This area dA. The length, the radius is r. This is a 2 theta. So the length of this element is r into 2 theta, and thickness is dr. This is r and this is a dr. So thickness is dr. So this area is equal to length into breadth. So that will be r into 2 theta into dr. So charge on this element dq is equal to sigma dA. So this will be sigma into 2 r theta dr. Now the good thing about this element is that all points of this element are at the same distance from point P. So because of this element, potential at P would be dV is equal to k dq by r. So put the value of k is 1 over 4 pi epsilon naught. Dq we have written here, sigma 2r theta dr, and then divide by r. So we get rid of this r, and now this is in theta and r. We want to write in one variable, so let me express everything in terms of theta. So for that thing, just see that this is a diameter and this is a semicircle. So angle subtended by diameter on a semicircle is 90 degree. So here if I draw this line like this, so this angle should be 90. This is 2r diameter, this is theta, this is small r, right angle triangle. So this small r should be 2r cos theta. So small r is equal to 2r cos theta. So small dr would be minus 2r sin theta and d theta. Now put dr, so everything will be now in theta. So dv will be 1 over 4 pi epsilon naught and 2 sigma theta, and dr is minus 2r sin theta d theta. So this 2 will get cancelled here. So v will be integration of that whole thing. So let me write the constant thing outside. Pi epsilon naught, and here sigma into r will also be here, sigma r, and taken outside out of the integration. So the variable inside are theta sin theta d theta and the limit of integration. So as I take this theta from 0 to pi by 2, all the such element will be covered. So my integration limit would be 0 to pi by 2, and we will integrate it using integration by parts. Sigma r by pi epsilon naught is outside. Now the first function is theta. Second function integration is minus cos theta 0 to pi by 2, and then minus integration of 0 to pi by 2. Again integration of theta is 1, and integration of sine theta is again minus cos theta and d theta. So this part integration, if you put the limit, when I'll put pi by 2, this cos theta will 0. When I'll put 0, this theta will 0. So this is going to be 0. And this is simply cos theta minus minus plus integration of cos theta sine theta. Put the limit, you will get 1. So overall, we are going to get V is equal to sigma r by pi epsilon naught, and this is the potential at an edge due to this whole disk. Thank you.